folks, welcome back to the shop. Frank here. I've got an interesting machining project I'm going to get started on today. I want to build a fixture plate for my rotary table. I have a 12-inch rotary table for the mill. So what I'd like to do is mount the table to the mill. I'll show you how I go about doing that. And then I've got a piece of 12 by 12 by 1¼ inch thick aluminum plate. So we'll put that in the Kurt vise, drill some holes, mount it to the rotary table, and continuing to machine it there. Ultimately, the plate will provide a series of drilled and tapped holes, providing a lot of flexibility for clamping work to that table for specific milling operations. The advantage of making the table or the plate out of aluminum is that it can be sacrificial. That is, you can mill the entire side of a component that's clamped directly to the table, take a couple thousandths of the aluminum with it without having to worry about it. You can always resurface that plate at any time to get it flat again. Provides a lot more flexibility in clamping work to the fixture plate than you have on the rotary table itself, a series of drilled and tapped holes versus 6 T-slots. And you don't have to worry about marring or damaging the rotary table when you're milling something, or having to pack components up off the rotary table in order to have clearance to mill the entire side of a part you're rounding the corner or making a curve on. So it gives you a lot of flexibility and simplifies that task considerably. So we'll get started with that, mounting the rotary table to the mill, and start milling this piece of aluminum plate stock. All right, so let's get started. These are precision ground stones. From Lance Balsey, who is, I think his YouTube channel is 26 Acre Maker. And the idea here is just to catch any burrs that are on the table. I don't feel any. It's surprising how good the shape this mill is in. It was, I think I said in some previous videos, this mill was actually a spare in a shop, and I don't think it was used, very little. I mean, there's still scraping visible on the knee here, and this magnet's designed to pick up 400 kilograms. All right, the bottom of this should be clean. This rotary table weighs 147 pounds. Bottom of this feels pretty good. Something right near this clamping point, but otherwise don't really feel any issues with it. Maybe 20 years ago, I could have picked this thing up. Actually, I did pick it up when I got it out of an estate sale. It was all I could do to pick it up. It's very nice. It was a little bit rusted when I got it. I cleaned it up. There goes my Bamboo A1 printer. Just finished another job. I see one little spot here, but not bad. There's one over there. This is the first time I've stoned this table. All right, we'll come back and do this again before we tram it in. All right, I'm going to get the bolts in here. I'm going to go ahead and set this vise up again as well, so I'll have it if I need it. Now I'm just going to snug these down lightly for the time being. While I've got my stones out, I think I will take a pass here on the vise, just in case I have any I don't feel really any burrs here, so it's in good shape. Okay, All right, when I want to measure this bore, just going to 1.193. That's 30 millimeters. .3. I don't think it's a tapered bore. I think it's, my first thought was it would be a Morse taper, but I'm looking at it now and I think it's, I'm just going to use the calipers here. Yeah, I'm getting 30.61 millimeters. 1.2 inches. This is a new pair of Starrett calipers. I had another pair of calipers. I have another pair of calipers that reads, it's off by 3 or 4 thousandths. So I decided to get a new decent pair. Actually, I got 2 pair, one here for the mill and one for the lathe. That's the other one's a Mitutoyo. Alright, so I'm going to go down toward the bottom just to make sure it's the same. Well, it's not. I can tell. Okay, it is tapered. Theoretically, if I measure this end of the bore, I can figure out what, I can tell it's tapered. .2, 1.222, 1.221. So that looks like, according to Machinery's handbook, that's number 4, 1.231. Small end is 1.15. Let's do that. Go down to the bottom. See if we get 1.15 approximately. And 1.14. Well, it's a specified distance down, so I don't know what that, I haven't done that. Yeah, so that's number 4, Morse taper. All right, so I want to tram this table in a couple ways. One, I want to get this slot parallel to the x-axis. I've got the table locked on 30 degrees, which would bring one of these slots in line with the x-axis. So I just want to make sure I've got this in line. So definitely off a little bit here. So this is a tenths indicator, so I'm 5 thousandths there. All right, so it's basically 5 thousandths off. All right, I think that's as close as I'm going to get it. It's about 1/1000th or 1,000th, couple of tenths. This is a Starrett dial indicator. What is it, number 196? So it's a back plunger. It's got a large tip on it. And I'm trying to tram in this table. So I'm reading, the dial says 81. This is thousandths, divisions or thousandths. So that says 81, 81, 79 and a half, 79, 78, 79, 80, 81. So it looks like it's 3 thousandths out from one side to the other. All right, I'm pretty consistent from this side, from the front to the back. Let's look at it. That's 79 and a half. Over here, I'm reading 79 and a half. So the nod is correct. What I have is from this side where I'm reading 81 to this side where I'm reading basically 78. So I need to tilt it a little bit counterclockwise. So there's four bolts here that hold the tilt. They're all 19 millimeters. Tight. All right, and then there on the side here, so here's basically a worm screw, which will rotate or tilt the head. All right, so now I'm showing 80, no, 79, 80, 81, 80. So I need to come a little bit more. All right, I've got the table trammed in pretty well. It's basically within 1,000th all the way across the .12" diameter. So of course tramming in this slot is, I don't know how useful it's going to be. I have it set on 30 degrees. Obviously if I change the rotational setting, it would change that. So at this point I'm just trying to get a close reference. All right, so I just finished drilling with an end mill, really, milling this hole, which was originally drilled to 15/16. Milled it out to 1 inch. So I learned the hard way about chucks on the mill. And I had previously purchased chucks which had the taper attachment, and they kept coming apart. So I finally bought chucks with the integral R8 taper shank. Haven't had a problem since. And I do like these keyless chucks a lot. All right, we're going to drill a couple of 1/2-inch holes here and here. I want that to be recessed a little bit more. All right, so it's recessed almost 1/4 of an inch. That's what I want. All right, so what I've been doing up to this point is just prepping this plate. This is 1¼ inch aluminum, 6061, 12 by 12 square. Came from McMaster, and I have to say it's right on the money in terms of dimensions, and it's pretty square. So anyway, so what I've been doing is just prepping it for to hold it down on the rotary table. So center hole to center it, and then a couple of bolt holes here just to hold it down in the slots. And they're 3 inches off center, which, you know, is, I'll probably do another one at 5 inches and when I ultimately we get to that point. So I don't want to risk the end mill grabbing one of these chunks and throwing them. What's going on with my two puppies? Huh? What you doing? Come here, Brew Brew. Come here, Butchie. How you guys doing, huh? You being good boys? Yeah? You have a hurt paw, Brutus? Do you have a hurt paw? Let me see. Is there something? It's okay. It's okay. It's okay. You licking on that a lot. Don't see any blood or anything. I think Brew Brew hurt his paw. I don't know how. Don't know how. He's limping on it a little bit. All right, so I've got a boring bar here. So the issue I'm going to fix right now, this next operation, is to make sure this hole is concentric with the Morse taper in the table itself. Now, after I centered the quill over the hole in the table, the Morse taper in the table, and then mounted the plate as accurately as I could drill this hole, I'm a couple of thousandths off. We measured 3 or 4 thousandths off. So what I'm going to do is use a boring bar here to just true up this hole so it's concentric with the hole in the table. Now eventually I'll have a pin which will fit in the Morse taper and come up through this hole so that placing this plate back on this table will be repeatable and it will always be centered. So I have to work on that at some point. I have ordered the Morse taper, number 4 Morse taper adapter to number 3, and also a blank end Morse taper 3 plug, basically blank, that I can turn to fit the hole here. So that'll be another operation. I have to wait for that stuff to come. But meanwhile, let's true this hole up and then go from there. Okay, that was easy. So just took a few thousandths off the inside of this hole so it's concentric with the mill table Morse taper. Okay, we've gotten to a good, I think, a good stopping point. I'm going to wrap up the video at this point. We'll come back next week continuing to work on this fixture plate. We got to mill the top of it flat. We've got to drill a bunch of holes. We got to tap a bunch of holes. I'm thinking about maybe even a couple of slots in the surface for mounting a fence or a pair of, you know, if I could put in, like, for example, a right angle fence or something like that. Don't know about that yet. We'll see. So we'll come back next week and continue working on this. Thanks for watching. We'll see you then.